Welcome back. Did you miss me? I missed you. Let's get started again with our population effects on water quality. So we said that communities across the country are starting to face challenges in maintaining healthy water and making it affordable for everybody, right? Water is one of those things that we absolutely need. All organisms need food, shelter, and water. So this is a big deal. Our point that we ended on was that an increase in population size means that there's less water per person. Now I've got a graph that we're going to talk about so you can really see exactly what I mean. Here's how we conserve water though. So we use water barrels, and if we get our garden here at Emeru up and running, I'm going to start some water barrels. Pretty much what they do is they sit at the end of your e-spouts where it would usually just shoot out of your gutter and into the ground, and it actually collects that water so it doesn't go back into the ground. It collects in a barrel, and then you use that for things like watering your plants or maybe washing a dog. This wouldn't be drinking water, it's just an extra collected water. Another thing you can do is turn off the faucet when you brush your teeth, wash the dishes, anything else that you use water for, don't let that run. Take shorter showers. I told you all I had a roommate who took 45-minute showers. Like, that's not an overestimation. She actually took 45-minute showers. And I asked her one day, I was like, what are you doing in there? It takes forever. You're wasting a lot of water. But you can conserve water just by shortening your showers. You can ration water a little bit. So I'm not saying drink less water because water is healthy for you, but really be mindful of the water that you are using. Is it going to an important cause, or are you wasting it? And then watering plants at night and early morning, that's just good practice for being a good plant parent. They take up more water during the night and early morning because their stomata are open as well. Okay, so those are your methods of conservation. Here's that graph I told you I wanted to talk about. So population increase in water resources is the label of our graph. On the left-hand side, you have a yellow chart. It is the world population. In 2007, it was 6.6 billion people. Projected growth is in 2050 is 9.3 billion. So our population is definitely still increasing. I remember the day we turned to, excuse me, made it to 7 billion people. We had a little party at school. It was crazy. But we are projected to just keep increasing. But here's the thing. Here's our source of water. If you look on the right side, it's the blue bars. So we have 200,000 cubic kilometers of water that are available to drink. We call that potable. And from 2007 to 2050, that amount of water doesn't change. So even though our population is increasing, our water is staying exactly the same, which means that if you divide if you tried to do per billion, which I can't do the math right now, but you would have more water per person in 2007 with the smaller population than you would in 2050 with the larger population, simply because when you divide 200,000 by 9.3 billion, it is a much smaller number than when you divide 200,000 divided by 6.6 billion. So as our population increases, the result is that there is less water available per person. Now we know with all resources, it depends. Your availability of resources really depends on your income and the money that you have, which is really, really sad, but that's the way the world works right now. So maybe being a wealthier population, and think like the difference between eating dinner on a plate and in your carpeted or wooded or laminate, even laminate floor, versus eating dinner in a hut. So just that serious different. Even the people who don't have a lot of money here in the U.S., that's nothing compared to the people out in our third world countries who have just even less. But resources depend on how much money you make. We know that, but that's a topic for another day. Moral of this story is that as the population increases, we have less available water per person for drinking. Population effects on water quality. So that was quantity, this is quality. As populations grow rapidly, healthy standards find it difficult to keep up. More people, more pollution. This leads to an increase in waterborne illnesses as pollutants build up. More people, more pollution, more sickness. There's a direct correlation, a direct effect there. And I think this is our second to last one. Wastewater treatment system. So The major aim of a wastewater treatment is to remove suspended solids before returning the water back into the environment. Treatment facilities are unable to filter out all contaminants, so we do treat our water. We do. We take the solids out. We do not, however, have the ability or can do it in an economically wise or advantageous way to take out the chemicals of water. So we are cleaning our water, but there's some things that we just can't take out. Drinking water treatment system, here's how it works. So it removes small and large sediments from water. Water is forced through filters to remove smallest particles, and they also remove biological contaminants. So we take our water from a source like a lake or a well, or in our case a river, and we filter it, and then we put it through some pumps, and we circulate it some more, and we put some, these are filters. So we take out all of the particles. Maybe this is like a filter that gets the big stuff, and then we get the medium-sized stuff, and then we take out the smallest of stuff, and then we treat our water just a little bit with some chemicals, and that hopefully will take out any biological contaminants. Then we filter it into a system, let the water settle so the sediments drop to the bottom, and then we filter it some more, or we move it some more, put it through another filtration system to try and get everything back out, where it is eventually disinfected, or we take out like as many bacteria and viruses as we can, though that's not always how it works. We move it to a water storage system like a water tower. That's how it works. It's a little bit confusing. You wouldn't be tested on that. The moral of the story is know that we do filter our regular tap water, though it is not filtered as much as you would think. And lastly, we'll go through these exit ticket questions real quick. So identify these as point source. Remember, we can point our finger at where the contaminant is coming from, or non-point source pollutants. I have hog manure, common industrial fertilizer used on many farms. So do we think hog manure is point or non-point? It is actually let's see what I put down. Point source pollution, because you can identify exactly where it comes from a hog farm. A common industrial fertilizer used on many farms. Now, if it's an industrial fertilizer and there's only one farm on the system, then it's likely that that's where it's coming from. But for the most part, our river systems have many farms along their banks, remember, because we talked about how fertile the ground is. So we usually classify that as a non-point source type of pollution. And then number 3, a chemical like Gen X released into the river as chemical waste product from a factory. That is point source. You can point your finger at exactly where the pollutant comes from. All right, hope you had a good day and enjoyed these 2 lectures. Goodbye. In a second. Can't find the end button. Still can't find the end button. No buttons are doing it. Oh, that's fun. Great. That's cool. I'm glad you're that version. End, escape.